Anders out. Hi guys, Mark from D&P. It's 2015 and I've been thinking about what I can do with the YouTube channel, and I'm looking back at the videos that I've done in the past, and I've realised that they're basically all about what has been done, and I haven't done any videos of all the work that's gone into making this car. There's a couple of slideshows and things like that. So in 2015 we're going to do some more videos where we're actually going to be working on the vehicle and some fabrication, some engineering, etc. So with that in mind, today we'd always got it in mind that we were going to change the solid mounted steering wheel, if you like, for a quick release unit. So we treated our little project on my own camera to this little beauty, which is a quite expensive quick release steering wheel adapter, and in this video I'm going to show how we fit it. Right, step one, we need to take the steering wheel, which is attached to the column, off. There should be a roll pin which will be fitted through here, but we've just been using a bolt temporarily, so we're just taking that out, and this should just slide through this bearing. So there's a bearing down here and there's a bearing up this end. Slide that out, should come through there. There we have it. Okay, so just show how the steering wheel and column is bolted together at the moment. So we've manufactured this using the lathe and welded joints and machine joints and things like that. We machined this plate, which basically is just the same size as this, which is called the Boss, with appropriate hole spacing, just bolted together with those, well, there should be 4 bolts and there's only 2 at the moment. This is a standard Boss for this wheel, which is made by Mountney, which is like a Momo rip-off. This is like a collapsible section, which we will be getting rid of. I'll explain that later on. So what we're going to do is we're going to machine away this section so that it's down to this diameter, and the steering adapter that we've got is actually a weld-on one as opposed to a bolt-on one, because I think it's neater. So the idea is that this section here will get bored out to accept this section here, and we're going to be quite cunning when we do that. We're actually going to do a shrink fit. So what that means is the bore in this is actually going to be smaller than this size, which is 20mm. And what we're going to do then, we're going to put this little unit into the freezer. We're going to put this unit into the vise, and then we're going to heat it up, get it to about 500-600 degrees, and then very quickly we're going to drop this inside there, because this will have expanded and this will have contracted, and then when they both reach the same temperature, normal room temperature, you will never ever shift that, no matter how hard you try. We are going to put a couple of little tabs of weld on, but we've done a test on this and it's phenomenally strong, a shrink joint, so that's what we're going to do. Once this goes back into the adapter, which I'll attempt to do now, like that. So that bit is going to be welded there. So you can see, if we put the steering wheel straight back onto the adapter, once this is welded into that, it's actually going to move the steering wheel around about 20mm away from us, which we don't want. So I've actually got a billet of aluminium that we're going to machine, that's here. So we're actually going to machine a 20mm spacer, which will slot just between there and the steering wheel, and bolt back up, and I'll keep the steering wheel in the same spot, but we'll then have a removable steering wheel. Well, let's get the steering wheel off then. Not going to need them anymore. Alright, just a little tip, if you've got a wife like me, or you live with your mum or whatever, and you want to use their freezer, putting greasy parts and things in, get a nice clean bag, pop it in there, seal it up, and you won't get any grief. Bottom of the freezer is the coldest. Right, what we need to do now then is turn down that boss and get it to the right size so that we can then bore it out and fit the quick release in. Okay, so we've got it down to the diameter we want it now, and now we're going to drill it out just as a rough size to about 16mm, and then we can bore it out accurately. Okay, so the next step we need to do is bore it accurately to 19.9mm. Right, so what we've got now is a hole bored at 19.9mm. Got a little bit of weld prep on it. There you go, as demonstrated by Dave. Got a weld prep on the edge. And now what we've got to do is heat this bit up and bring the other bit out of the freezer. We have put a mark on there so that we can line up the master spline. So, break out the blowtorch. Done. It's not bad. So now that's been allowed to cool down a little bit, this should slip on there. And we've got a nice tight quick release steering adapter. Well, that's not the end of it, because what we've got to do now is we've got to make a spacer, because that replaces this, which is much longer, which brings the steering wheel closer to you. So we need to make a 20mm spacer, basically an aluminium ring sits between there and then the steering wheel sits on top of it. So we'll have a look at that now. So just before we start making that spacer, I just wanted to show a little test that we've done, just to see how strong the heat shrinking process is. What we've got here is an M14 high tensile bolt that we cut the threads off, then we machined it down fit just inside here, so it was actually 0.05mm bigger than this bar, than the hole in this bar. And then we did the same process as we did with the steering shaft. So in fact we didn't even chill this bit. It was cold anyway. We just heated this bar up in the vise, and this just dropped straight into it. We then let it cool down, and then we thought it's only scrap, so we'll do a bit of a test. So this is a 15-inch adjustable spanner. I'm around 240 pounds in weight. So let's see what I can do with this. That is actually twisting the bolt slightly on its shaft. Well, I cannot budge that at all. And that's with a 0.05 size greater than the hole it's going into. With the steering shaft we made it 0.1. You're never going to get anything like that kind of pressure on a steering wheel. Having said that, we are going to just put a couple of runs of TIG round the shaft, just in case when we're running it on a track, if we get a scrutineer who wants to know how it's put in, he might not be familiar with heat shrinking, so we will put a little bit of TIG around it and then it'll be fine. But we know that's strong enough without it. It's just a bit of extra safety. Ooh. Right, the spacer. Right, as you can see, we've got a billet of aluminium here, 20mm thick by 100 by 100. Plenty big enough to make our spacer from. I've just measured this across. This is 81. I'm actually going to start with making an 85mm ring, or a circle, should I say, and then we'll go from there. So the first thing to do is find a centre, put a hole in it. I'm only using this, just a rough measurement to find the centre, because you see we've got plenty of space all the way around it, so I'm not too concerned if it's not very precise. Make a little mark, start the drill. That'll do. So we've moved over to the milling machine now. The reason I'm drilling this on the milling machine instead of the drill press is that I want it to go, the hole to go through it exactly 90 degrees, was closest damn it to to the piece of billet. That'll mean when I put it on a mandrel in the lathe, and it'll spin true and won't have any wobble or anything. Sometimes if you drill them on the drill press, you can actually get a little bit of flex on the casting where it comes off the arm, and it can, with thick material, it can actually drill. The drill can run, so the hole on the back side isn't in the same spot as on the top. So that's what we do on the drilling machine. So the first thing we've got to do, sorry, that's what we're doing it on the milling machine. The first thing we've got to do is find the centre. That looks pretty good. There we go. Lovely job. Get rid of that one. Come back in with a 12mm, because I'm going to use a 12mm mandrel in the lathe. Okay, so we've got a nice 90-degree hole in our piece of billet. So can just deburr that, and we'll get it mounted on our mandrel, put it in the lathe. So we've now got it mounted on a 12mm mandrel, tightened up, and we've now got to make a square something round, and around 85mm in diameter. Right, let me explain what we've got here. We've come off the lathe. This basically now is 85mm in diameter, and coincidentally, not coincidentally really, that is the same as this, which I've cut off the boss to make a pattern, because obviously we don't need this anymore, this is junk. So what I've done, I've used the same size mandrel at 12 through into one of the T-slots, and clamp the bottom piece down, the main thing that we're working on here, clamp that down solidly onto these cunningly spaced pieces of 12mm bar. The reason I've used those, I wanted them exactly the same, which they are, I've checked that, and I also needed to be able to have clearance for the drill to go through the holes, through the material, and not drill into the bed, because we don't want that, that's bad. So that's very, very secure. On top of that, I've cut off this bit and just mounted that on the top, and all I've done is just basically put 2 fingers around in each direction and just feel it for the edge. It's a spacer, it's not a rotating component or anything like that, so just feeling it, it's spot on. And then I've clamped it down with these 2 units here. So all I need to do now, with the machine not running, is basically feel for the holes and make sure I've got the drill straight down through the holes that are in here, and then just continue on through the piece, and then when we take this away and throw it, this should bolt perfectly to the steering wheel and to the quick release adapter. Now, to do it more accurately, it'd be nice to have had a rotating table with degree settings on it, so I could have done each one at 60 degrees, with being 6 holes in a full circle. But for this little project, this is perfectly good enough. As long as nothing moves, we'll be fine. Right, well, I messed up there a little bit. Nothing major, but top tip for when you're doing some milling operations, make sure you've got enough travel on your bed for the piece that you're working on, which I hadn't, so I couldn't reach one of the holes. And on the other hole, when I'd been adjusting it and just getting it spot on, or what I thought was spot on, I'd just put one of those clamp downs just slightly too close to the edge of the hole, so I couldn't do it. But what I've done, I got 4 holes through it, and I've just put some bolts in there temporarily, so that's absolutely spot on in place now. So I just need to clamp it back down to my table, making sure that I can reach these 2 bolts with the drill, and we're laughing. So we have our plate with its 6 holes around the outside, and they all seem to line up. So all I've got to do now is take the middle out, because the middle's not doing anything. So I'm going to put a hole saw up the middle, then just clean it up. It's going to be about 52-53 millimeters on. Just see how well this hole saw cuts. But I know I've got some leeway there, so we'll just see how it goes. Got to go really slow with the hole saw. That's the piece off the lathe, all cleaned up. I wouldn't advise using hole saws on lathes. That was a rough operation. That I didn't like that at all. But it's just about done. They're alright for going through thinner pieces, but there's too much friction on the edge of the hole saw because they're not perfectly round. So I didn't like doing that very much. Anyway, that's all done, and got that in the vise ready. So just got to pop it together. Can't get much better than that. Tighten them nuts and we'll show it when it's going on. So, the moment of truth. There we go. One quick release steering adapter. Sorted. Just before we end this video, I did say earlier that we were going to TIG weld the spline section onto the steering shaft. So the last bit is Dave showing off his TIG welding skills. I'd be interested in what you thought of the video. Did you think it was too long or too detailed, or do you actually enjoy seeing the construction process? Either way, please let me know in the comments, and like, subscribe and share the video if you enjoyed it. Thanks for watching.